Hello, Colton. This is now section 1.6. We're graphing special functions today. Special functions. The two main types of special functions that we're going to be graphing is something called a piecewise function. And then we also have absolute value functions. Absolute value functions. There's one other one, but I skip it. And maybe they don't even have any questions on it. I don't know. But it's something called a greatest integer function or a floor function. So maybe I'll talk about it, but we won't graph it. Okay? So those are the two special types of functions that we're going to talk about in this lesson. 1.6. Okay? All right, from yesterday, after doing whiteboards and stuff, I know that you guys are like super pros at graphing linear functions. So a piecewise function shouldn't be too terribly difficult for you because it's graphing like two of them at the same time. That's not too bad. Okay, here we go. Graphing a piecewise function. I want to go to one that already isn't graphed for you. Can we? I don't want to do that either. Let's go to this one. Yep, we'll just stay on the same one. I wish they gave me a blank graph. Every time they give me an example that says graph it, they always graph it for you, and I don't like that. That's one thing I don't like about this book. Okay, so graphing a piecewise function. All right, here we go. This is what a piecewise function looks like. It still has f of x. You see that? Equals, but now it's saying, okay, we have two different types of function, or two different scenarios that are going on, right? This is your x coordinate, and this tells you what your domain is, okay? And domain is x's, right? Left and right, okay? So we have a domain that tells us what's happening on the left side of 1, or less than 1. This is on the left side. And we have something that tells us what's happening on the right side of 1, right? Which function tells us what's happening on 1 or exactly at 1?
The top one.
How do you know the top one? Because it's equal to, right? So on the left side or equal to 1, it's doing the top function. And on the bottom, it's telling us what's happening on the right side of 1. Got it? Okay? So here's what I do. That's my domain. That's the thing that I look at first because I want to know where it's switching at. Like, where is the domain switching from one function to the next function? It's switching at 1. Agreed? 1 is where it's trading off, okay? So here's what I do. When you go to graph this, I locate where 1 is on my x-axis, okay? Here's where 1 is, and I'm gonna like imagine there's a dotted line there, right? Like on the left side of this function, it's doing one thing, and on the right side of that line, it's doing another thing, right? I have a linear function on the left side and a linear function on the right side. And all I have to do is graph the two, okay? So on the left side, or less than, it's doing x minus 3. So I'm going to go down to the graph. X minus 3. This guy right here is the graph of y equals x minus 3. Okay, let's make sure that they did this right. If I were to graph that, where would you start? You start at -3. Did they start at -3?
Yeah.
Yeah. And then they go, the slope for this is 1 over 1, right? So I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and I draw my line, except for I don't want to graph it if it's on this side of that line, right? I only want to graph it from here down. Does that make sense? So I'm cutting my line short, and I'm only graphing it to the left side of that dotted line. Got it? That's what that first piece looks like. Now, before I move on to the second line, I have to decide on 3 exactly. Is this going to be an open circle or a closed circle? Closed. How do you know it's closed? Right here, this function, we said it was equal to for the top one, so we're going to go ahead and fill it in as a closed circle. All right? Now, when I start my graph up above for the right side, I know that's going to be an open circle on the line, right? Okay, so let's go and talk about this one. This one is saying 2x, okay? So I'm looking at the graph of y equals 2x. Okay, so let's see. If I'm looking at y equals 2x, that's kind of in mx plus b, but what's my b value? 0, right? So if I'm doing that, I'm going to start at 0, and I go, what's the slope? Up 2 over 1. So I go up 2 over 1, up 2 over 1, up 2 over 1, and I draw my line, right? And it goes like that, except I only want to graph him if he's on the right side of that. So I'm only going to graph this little chunk, and I'm going to stop him right here, right? I'm only graphing him on the right side of that line, and here, where he touches that line, is going to be an open circle. You see how that piecewise function looks? Okay. And that's it. That's all. So find where he's going to switch from one function to the next. I kind of draw a dotted line. Then you want to maybe erase the dotted line because you don't want a dotted line on your graph. So I'm going to get rid of him. And now he looks better, okay? So open circle to the right is what he's doing there. Closed circle to the left is what he's doing there for that function. Got it? Shall we practice on another one? Let's see what another example looks like. Let's go to, oh my heaven's sakes. I don't like that. Let's do the one that they have here then. Let's do the check one. Okay, so go to here and let's go to the check. This guy, we're gonna graph this thing. Do you see where it says check? Yeah. And he has this, he's got it written like kind of small. We're gonna do this check button or check number. Okay, now the problem with this one is there's 3 pieces. Okay, so where does he switch from the top one to the middle one? Where is he gonna, oh, he doesn't switch a very good spot. Ugh. Here it's only talking about less than 0 and here it's starting at 1. Ugh. Okay, I'm gonna make a dotted line there. I'm gonna say 0 is here and 1 is right here. Do you see that? Okay, so 2/3 x is what's gonna happen on this side of that line, and on this side of this line, it's gonna be at 3. Okay, what's happening between those two? Nothing. I have nothing graphed in between. I don't know what happens between 0 and 1. Yikes. What?
So for the top function, would that be like the circle or fill in
Yeah.
an arrow, and then the middle one would just be
A horizontal line. Yeah, exactly. Yep. Okay, so we're gonna graph that right now. So we've got our lines determined for that. Then let's go ahead and do the let me get my eraser in here. Let's do the other one. Let's talk about the middle one stops at 3 and he starts at 4. So 3 is here, 4 is here. Okay, so let's check this out. You ready? This chunk on this side of this line, this is going to be my top function. This chunk in the middle here, that's going to be my middle function. And over on this right side in between there is going to be my bottom function. You see how that works? Okay? And that's what we have going on here. All right, now if I say list the domain for this. List the domain. Does he go forever to the left?
Yes.
Will my function continue to go forever to the left?
Yeah.
Yeah, will my function continue to go forever to the right?
No.
Yeah.
On this end it will probably, right? Like it'll go forever that way. Will it touch every value in between?
No.
Because he has a gap right here and he has a gap right there, right? Okay, so for domain, if we're talking about domain, he doesn't touch. He doesn't touch what? From what to what?
0 to 1.
0 to 1 and from 3 to 4. He doesn't touch 0 to 1 and 3 to 4. Does that make sense? So that's my domain. He's going to touch everywhere, but he's not going to touch 0 to 1 and 3 to 4. Got it? Okay, let's see what we've got going on here for a function. So I want 2/3 x, all right? So I'm just going to go off of here and I'm going to graph 2/3 x, and then we're going to fix him, okay? So, y equals 2/3 x. What's the b? 0, so plus 0. So when I'm writing my linear function, I'm going to start at 0, and I'm going to go up 2 over 3. Up 2 over 3, or down 2 to the left 3, and down 2 to the left 3. So my function looks like this, right? Except I'm only going to graph it on this side of this line. You see that? This side of that line. So I'm only going to go from here on down, and that's where he's going to stop, okay? From here down over this way, and he's going to have an arrow on that end. Got it? This guy right here, is this an open circle or a closed circle?
Close.
How do you know he's closed?
Because
Because it's equal to 0. So I'm going to do a closed circle. I'm going to fill that in and make him really, really closed. Okay? All right, now 3. This is the function y equals 3 here in the middle. How do you graph y equals 3? It's a straight horizontal line, and he's going to go right here in between, right? Okay, on the left side, is he going to be an open circle or a closed circle? Right here. Let's look at this. At 1, he is touching at 1. He's equal to 1, right? So he's closed. Is he equal to 3? Yes, so he's closed also. So closed circle, right? Okay. Now the next one, the last one on the bottom is y equals negative 2x plus 5. Y equals negative 2x plus 5. That's what we're graphing on this side over here. Okay? So where do you start that at? 2, 4, 5. I'm going to start right there at 5. And then from there, I'm going to go down 2 over 1. Down 2, right? This is 2 over 1. Okay? Down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Heavens, heavens, heavens. This is what that line looks like. Okay? Except, I'm only going to graph him from this line over. So I'm only going to get this little bit right here. You see that? Okay, so I'm going to erase all this other junk right here. Let's get rid of him. He's going to go down 2 over 1, down 2, right here, here, and on down. Should this guy be an open circle or closed circle? Closed. Because he is equal to 4. So, this guy, closed circle, this guy, closed circle, and closed circle, closed circle. So everything that's in black is my final. Well, I did it black. It's gray, whatever it is, right? I tried to make it black. So everything that's in black, that's my final answer. Holy cow. Is that nuts? Hopefully there's only 2 pieces for each one. And they touch each other. That would be nicer, right? I don't like these gaps in between. Yeah. Icky. What?
I don't like touching each other.
I don't know. Okay? Good? All right. Let's go to example 2. And I don't think they're going to have us graph this, but let's see what we've got. The football coach is ordering new jerseys for the new season. The manufacturer charges $88 for jerseys when 5 or fewer are ordered. So let's look at this right here. You see this little line? 88 times X if we're going to order 0 to 5 of them, right? Okay? Now, if we're ordering more than that, like 75 is my next dollar item, and that is for 6 to 11 jerseys, right? So if we're going from 6 to 11, then I get charged $75 a piece, right? The more I order, the less it is per piece, right? So let's fill in the domain for that one. We're going 6 to 11. 6 is less than X, which is less than 11. Is it equal to 6 and equal to 11 or not? Yes, so I want to put equal to signs right here. There and there, okay? If I order more than 11, I'm going to go down to $65 a piece if I order between 12 and 29. So I would say 12 is less than X, which is less than 29. Okay? Is it equal to? Yep. And they say for anything greater than 29, it's going to be $56 a piece. Does that make sense? Okay? So that's how we fill that in. Yes, sir?
Technically, wouldn't it be only whole numbers?
Yes. So I don't know why they didn't write this right here as X is greater than or equal to 30 instead, right? Because it could only be like whole numbers. So you can think of that bottom one as being that. Does that make sense? Since we're only doing whole numbers here, okay? So that's how that works. Okay, B says evaluate the function. So we're given these 3 questions. What would it cost to purchase 11 jerseys, okay? There's 4 different functions going on. If I'm purchasing 11, am I doing the first one, the second one, the third one, the fourth one? The second one, because 11 jerseys is going to be at the $75 range, right? Okay? So does that mean it's going to cost me $75 for 11 jerseys?
No.
75 times 11. I'm going to plug 11 in for this X, right? Okay? So let's do 75 times 11. Does somebody have that number for me? 845? Did you do that? 25? 825? Thank you. Did you do that on your paper without a calculator? Good for you. Good for you. Very nice. Okay. What would it cost to purchase 25 jerseys? Is that the first, second, third, or fourth? 25 jerseys. Domain, right? That's a domain. Okay.
145.
If we take 25 times 11, say that again. What is it? Not 11. What are we doing? 65 times 25. I can't think today. Woo! 65 times 25. 1,625. Okay, 1625 for that much. Okay, now, then they say f of 29. What does that mean?
If you get 20.
If you're doing 29 shirts, that's just a different way of saying that, okay? If we're in 29 shirts, are we in the first, second, third, or fourth?
Third. Oh,
Technically third, right? We're on the last edge. We might as well buy one more and then our price goes down, right? I don't know. Okay, so we would take 29 times 65. We're at the $65 mark. What's that going to be? 1885.
That's not bad marketing.
Perfect. I know. Yeah, that's not very good.
Because then you could just order 30 shirts.
I know. We should just order 30 because that would probably be less expensive than ordering 29, right? It'd probably be cheaper. I don't know. We'd have to look crunch the numbers, right? Okay. So that's how we evaluate those. We plug them into which function they go into, right? Not you. Somebody. Or we'll throw things at him. Carson. All right. Go to the next page. This is what the function looked like. Oh no, that's not what the function looks like. My bad. Skip greatest integer function. We'll skip over him and let's go to example. I don't want example 4 either. Let's go to the top of page 51. Okay, so we're skipping a couple pages. Go to the top of page 51. It says learn graph absolute value functions. Okay?
Wait, what?
It's in the wrong boat. Is it saying .0000?
No, it's messed up.
Is it in scientific notation? Oh,
I want to open it. I want to see what's in the calculator.
kiddo, you need to put it in front of the window or something. Or you broke the screen of it. I don't know.
Well, do you have No, I'm snapping it. 'Cause I already
No,
have
you just wait.
Just use it.
You just wait. Okay. Alright, we gotta get going. I've got a low battery. Alright, up over greatest integer function. Greatest integer function we talk about in like trig class. So a couple years from now, we'll talk about greatest integer function. Absolute value though, is a function that looks like this, right? With the 2 bars. Absolute value is just talking about the positives, right? Absolute value functions, the bars. Okay? If you graph an absolute value function, he looks like a V. He looks like a V. That's what an absolute value looks like. Okay? We said that y equals x, or a linear function looks like a line. X squared looks like a U, a parabola, right? We talked about some of those. Absolute value function looks like a V. Okay? So he is a V going up at 45-degree angles, making like a 90-degree angle in the middle, right? That's what that absolute value looks like. Okay? Now, here's the deal. I'm going to give you a little hint because you're going to need this for your homework assignment. Let's say, put this off to the side over here. Let's say that I do absolute value plus 3.
You go up to.
Yeah. What that's going to do to my graph is going to go up 1, 2, 3, and then my V starts at 3 there, right? Okay?
And if it's negative, it's
And if it's negative, it's going to go down. Let's say I have this. Let's say the plus 3 is inside. Do you know what that does?
It just slides it over.
Slides it over which direction? It technically, so plus 3, you think it slides it to the right?
No.
When it's inside, it does the opposite sign. So it's going to go 3 to the left, and then my V starts there, okay? So that's a little hint for you. And make sure you put that off to the side. That'll help you take shortcuts later, okay? So plus 3 on the outside is going to move it up and down. If it's on the inside, it's going to move it left and right, okay? So that will be helpful for you to do a couple homework problems, all right? That's the absolute value function. Absolute value. Good?
So if it's a positive, it moves it to the left. But
If it's a positive, it moves it to the left. So then if it was y equals, let's say, absolute value of x minus 2, that would move it 2 to the right. He would look like that. That make sense?
Because when they both move it to the right, because absolute value is just the positive version.
Oh, good thought. So, I get that. But it just tells you when it's saying positive, then that means the y coordinate is positive. So in each one of these graphs, the y coordinate is positive because he's above the x-axis, right? He's above x for each one of them. The y coordinate is positive, right? So we're not talking about x, we're talking about y. That makes sense? Maybe? No? No? So absolute value is telling you what the y coordinate is. Right?
That is really good.
Yeah?